Thank you, Clojure West, for having us, and thanks for coming back from lunch to come hear us. It's always a little difficult in the big belly to come back, and the food's so good here. But all right, let's get started.
This is Beginner's Luck. It's our story about learning and teaching Clojure.
So the question comes up sometimes, why do you teach? And you may think it's the act of giving brings you something, and it's this eternal kindness that you're giving out to the world, and everyone gets along together, and it's a beautiful place when you do something like that. And there may be some truth to that, but I'd like to present you with a different reason, a slightly more selfish reason. And that's by teaching, you also learn. I can't tell you how much more I know about Clojure just based off the time I've spent teaching it. And you start to fall into this loop where the teacher helps the student helps the teacher, and you both get a lot better, a lot faster. Before you come up with the idea to your boss and say, hey, I'd like to bring some apprentices and interns into this company, you might get a few questions. Things like, a fear that you're not going to produce enough work now that you're spending all that time teaching someone else. Well, we've put that to the test, and what we found is having this extra pair really does not slow us down. Really, I don't think there's much to lose, and there's really typically only something to gain within certain caveats that we'll go over. But especially where there's a lot of folks here looking for that next developer to join their team, the one you make may be that right one. So developers out there, I'd like to challenge you. Your job isn't only to write code anymore. Sorry. That ship has somewhat flown. I say that developers now need to know how to mentor and teach, especially senior developers. Consider it part of the job description. I also like to hand you the idea that developers who are learning, the ones you are teaching, they don't tend to leave. So if you're having trouble hiring people, you might want to think about why your employees are leaving.
So let's jump over to how I got started. I had just enough exposure to programming that I knew I wanted to learn. So once I had the opportunity to transition from a small business owner to a developer, I took it. So where did I start? Well, initially I found a tutor. He was an incredible tutor, a lovely guy, and a CS master's from Stanford. And he helped give me some direction and context along the way. I think he got me going with learn code the hard way, and he made sure I knew my tools. And then from there, I got started on a computation and algorithms class through MITx and another software as a service through BerkeleyX. And I also started hitting meetups. As I grew my exposure to programming and varying language, I also grew my exposure to the substantial number of ways to learn online, as well as the varying styles of teachers and mentors that were out there. Eventually, I found myself at a Clojure meetup, and everything seemed to sync up for me. I was intrigued by Clojure's functional approach and instantly connected with the community. So I reached out to Daniel and asked if he would help me learn the language, and he was eager to help. What was cool is that Daniel and I both have pretty substantial teaching and coaching backgrounds, and we realized that if we took things a step further and analyzed our process, that we could help other Clojure developers be more successful when they embarked on their teaching adventure. One observation that quickly stood out was that we might all have the best intentions as mentors and teachers, but not everybody knows what they're doing. So what are some of the keys to having a successful session? Well, a successful session needs to have structure, and you need to find the right match. But not everybody is compatible. So what are some of the things to help you know if you're compatible? For one, you both will have equal levels of commitment and follow-through and motivation. You'll be able to recognize one another's strengths and weaknesses, and ideally there'll be an overall compatibility where you can relate to things outside of programming. And that might not always be the case, but it certainly helps if you can find common ground. And ultimately, you want to just give it a chance. So if it doesn't stick the first time, give it a few goes, and don't be afraid to flip things on their head. So if he's asking all the questions, then he might turn things to me so that I can ask more questions. And then just be sure to remember that this is a learning experience for both the student and the teacher. So now that you have a pair, what's next? Well, you'll want to get a grasp of what they might already know, so ask. Have a look at the projects that they've built or ask them about any classes that they've completed. And once you're working on problem sets or projects, you'll want to be able to determine their level of understanding. Knowing their level of understanding will help shape the direction of your sessions and makes goal setting far easier. So this approach is Bloom's taxonomy. Bloom's taxonomy helps guide the teacher through their assessment. Starting from the bottom or the base, the first skill acquired is basic knowledge. At this level, some of the questions you want to ask your pair revolve around remembering vocabulary and recognition. You might point to something specific on the screen or ask things like, what are the first two pieces when creating a function? Next, we explore their comprehension. You might ask them to explain, outline, or discuss the concepts you've covered. For example, what does this code do? And as their comprehension deepens, they can take the information they know and begin to apply it in new situations. So you might ask, what would you use to add expressions to a let? Or what tools might resolve this problem? Now that it's clear that they possess the foundational levels, we now need to discover if they are able to analyze and distinguish between different parts. When asking questions to determine your pair's ability to analyze, you use words and phrases such as differences, compare, separate, classify, or arrange. You might ask, compare the following functions. Finally, in synthesis and evaluation, they can compile information together in a different way by combining elements in a new pattern or by proposing alternative solutions. Additionally, they might present or defend opinions by making judgments about information or qualifying work based on a set of criteria. The questions that you would ask will run deepest at this level of understanding. They might be something like, what could we change to improve the execution time? Ultimately, don't forget to ask them what their understanding is and in different contexts. There are many layers to programming. Try to uncover where they are with each. For instance, they may not know Clojure, but they might have used Emacs in the past. Or you might even want to try to discern how well they can solve an algorithm using pseudocode. OK, now that you've established some idea of your students' understanding, it's time to create a structured session. Using the backwards design teaching method, you first establish your goal and then determine what fundamentals are necessary to build up to that given endpoint.
So if I may, if there's one slide you pay attention to in the theory, I definitely suggest it's this one. It kind of distills down some of the theory that Denise just went over into a formula that we've successfully used in a lot of our teaching sessions.
So you need to get creative. You need to break these things down into small pieces and get creative and make comparisons and give things context along the way. It's important that you also prepare. So preparing your session will set you up for success. I like to think of this one as one of those televised cooking segments where the chef has all of their ingredients nicely laid out before preparing a dish for their audience. Just imagine how lost the viewer would become if we had to watch the chefs scramble all over their kitchen with their backs to us while they collected everything they needed to get started. The measuring cups, bowls, pans, utensils, spices, parentheses. Even worse, even worse, imagine if retracing those scattered steps was the only way that you could make the meal yourself. Just remember, gathering the ingredients is easy. It's the sort of thing you already do, but the key to getting the most out, it's the key to getting the most out of your session.
Okay.
So what might you do if you don't have a goal in mind? Well, don't stress. Your goal just becomes teaching the fundamentals. So you can hop onto Project Euler or find a good algorithm to solve, or maybe break down a snippet of code in one of your current projects. Now it's time to make sure you have the right environment.
Yak shaving. Has anyone here ever done any yak shaving? Come on, everyone here has done yak. Does anyone here not know it? Not know what yak shaving is? All right. I'm not going to tell the whole story, but if step A involves step B, involves step C, involves step D, involves step E, and really you just wanted to do step A, that's shaving a yak. And I think we've all probably done a bit of that here. So let's talk about some of the tools that we use to get past the yak shaving. And we're going to be opinionated here. You might not like the opinion, and that's OK. That's one of the good things about opinions. But what we found is by being opinionated and making certain choices, it's made other things down the line a lot easier. So we're going to share those with you. Use a terminal-based editor. There are great graphical editors out there doing some really cutting-edge stuff, doing some really neat things, and that's cool if you're going to work solo. But if you're going to work with pairs, there are ways to share screens and work with graphical editors. I haven't seen a good one yet. So if you have a good one, I would love to hear more about it. But until then, we suggest using a graphical editor, something like VI, something like Emacs. And that's because of the next point, tmux. Tmux is a great way to share your screen and both be able to swap back and forth. You can both be at home, have headphones on, be talking on Skype or Google Hangouts, or use your program of choice on the telephone. Doesn't really matter. But you can be in a shared tmux session together, have your designer ergonomic keyboard, and they have their setup, and it doesn't matter. You're not having to switch back and forth. And also, you're not tied to one physical location, and that can be really freeing. What can help with that as well are SSH reverse tunnels. So the common, these are the tools we use at work every day, and the setup we use is we all run a VM on our laptop. You could have Windows, Mac, Linux, it doesn't matter what your laptop is. We all run a Linux VM. And we set up an SSH reverse tunnel through an EC2 node. And we have our config set up as simply as me saying SSH Denise, tmux attach. Suddenly we're working together. Here's another opinion. If you have 6 fingers, Emacs is not hard at all. Even if you have 5 fingers, it's not that bad, and it's worth knowing in your life. It's a really interesting, cool piece of software. It takes a little while to learn, but we feel the benefits outweigh the costs. Again, on our team at work, and when I'm teaching through the local user group, we all just use Emacs. And the facilities and libraries that have been built into it for doing Clojure development are super slick. So that's an opinion.
OK, so to go back over it, you found someone that's compatible. You know their level of understanding. You've set up your environment. You've established a goal, come up with a plan, and now you're going to make a rhythm. And you're going to rinse and repeat.
Repetition's great for teaching. The other thing that's great for teaching is getting over the hump of thinking maybe this isn't something you can do. Just try it. What do you have to lose? You'll find that most folks you're working with are happy to give you feedback and help you get to be a better teacher. So if it's something you're interested in looking into, there's often someone who's interested to learn. And again, you both get better. So let's put our money where our mouth is. Let's try some examples. So the thing to remember in these examples is we are not focusing on teaching you Clojure right now. Most of the folks in the room probably know or understand what we're going to go over in the examples. The idea is we're trying to show you what a structured teaching session might look like and think about how the flow works and imagine yourself doing that sort of thing. What if you have large amounts of customer data? So large they may not even fit into memory. How could you process such a thing and how can you get there? We'll break this into 3 problem sets, starting with problem 1. First problem set, how do you get values in a map? Well, you might write a function something like this. There's a function for that. All the Apple commercials where there's an app for that, I laugh every time I'm working in Clojure because every time I try and do something, there's a function that does it, that someone's written somewhere. So there's a get function that you're all probably familiar with that can take a map and take a key, in this case a keyword, and look the keyword up in the map and get you the value back. Not too surprising, huh? Well, when working in Clojure, you might notice that there's often a more succinct way to put something. So you can lose the get, and well, it turns out a map itself is a function that can take a key and look up that key and return you a value. Is there anything wrong with that, though?
Well, what if it's nil? What if the map's nil?
What if the map's nil? Sure, it'll be fun. Or not. So it'll go boom. So what's more common in code is to use the keyword as a function. If you're using keywords as your keys in your map, use the keyword as a function and pass it the map, and it's happy to look itself up and get the value back. Is there any problem with that?
Well, what if the keyword is nil?
So if the keyword wasn't hard-coded in there and you actually passed the keyword in, I'm sure it'd be fine. So that brings us back to our get function. If you pass it nil for a key or a map, it's happy to return the right thing and not blow up. So let's recap.
Get a value out of a map. Maps are functions that take keys, and keys are functions that take maps.
Fairly simple.
OK.
But notice how we structured the lesson. We built up, and then we tied it back to the beginning and summarized the whole thing. Let's go to problem set 2. Oh, any questions on that? I figured you all knew get. Problem set 2. How to represent an anonymous function.
What might you use an anonymous function for?
That's a good question. So anonymous functions are often used with another function called map. Map takes a function and applies it, or it takes a function and then takes an element out of the collection at a time and pops it into the function and then collects all the values back and gives them to you. So this type of thing is something you might see with a map function. The anonymous function part is I don't need a standalone function just to do that. It's a one-liner. I'll write an anonymous function here. And that's one application for anonymous functions. That's fairly common in Clojure. Okay. So you might see something back like this.
But this is Clojure. Isn't there a more succinct way to write that?
I'm glad you asked. Yeah. Yes, there is a more succinct way to put that. There's a shorthand notation for anonymous functions that looks something like this. And as you imagine, returns you the same value. Is that good enough, or is there an easier way to put this?
Well, what if it is just a single function?
So if what you're trying to do in the anonymous function is just a single function, you mean just pass that function? Simple. So again, to recap.
Longhand notation for anonymous functions, or shorthand notation for anonymous functions. Or if the anonymous function is simple enough, just try passing it the function.
Excellent. So again, this is not a hard concept. This is not an advanced concept. But the way you present it to someone you're working with matters. Let's do something a little meatier, shall we? So getting to our original question of processing large data sets. So large they may not fit into memory. I'll bet a few folks have a few clues on this one in here, but let's lay it out again. So perhaps we have this notation of a person, this notion of a person that we represent with a map, because maps are a great way to represent key value pairs, attributes of things. And this is a potential for a person. We put a couple attributes in there of height and weight, nothing fancy. Why don't we try generating a function to creating a function to generate a random person? So if we're going to create a reasonably sized random person, we can use the random function, limit how many digits we go to with our random numbers that get plugged in for height and weight. And if you're assuming centimeters and kilograms, because we all use SI, these are reasonable values. I'll bet the audience is asking themselves the same question I am. What if this person is a mutant? Let's find out. So we'll write a predicate function for that. This takes a person and looks in the map that's representing the person and returns true if they're a mutant. Again, if you're not as concerned with true false from your predicate in this case, and you want to return truthy falsy, is there a more succinct way to put this?
I don't know.
Now you do. So again, using the previous lesson about keywords looking themselves up in a map, we can just put a keyword in there. We're not worried about nil because the keyword is coded straight in there and we're not passing it into the function. Well, now we've got this random person function and we want potentially random mutants. So we could make them all mutants. That's a first easy step, right? Any test we had around this would be looking for occasional non-mutants, and those would fail. But this is a good first way to get that notion in the code. And it's going to always return us a true mutant. But is there a better way for us to solve this so they're not always mutants? Mix it up a little bit?
Yeah, maybe like a flip coin.
So maybe we could flip a coin. And potentially some of those mutants would come back as false. Or people would come back as non-mutants. How do we write our flip coin function? Well, remember randint that we spoke about a few moments ago. That may come into play to help. If we limit the randint's argument down to 2, it returns us a bunch of values that look like this. So that can easily be transformed to truth false by just testing for the presence of one of those numbers with a fairly simple function like this. And you get fairly random coin tosses. Back to our people generator. Now we want to generate a whole bunch of people. We don't want to just generate one. In fact, we want to generate as many people as we might need. So this is a little more complex of a function. Let's start by writing a docstring. You all write docstrings, right? So this describes what we're trying to do and lays out a plan for how we're trying to attack the function. And then we're going to just jump right to the solution and walk through the steps. It's only a couple lines, but there's a bit going on here, so let's talk it through. Look at our call to generate random person. That does just what we thought and returns us back the map. We're going to use cons to add that onto a sequence of a recursive call back into ourselves. Whoa. Do you see any issues with that? Does that make sense?
Will it ever stop?
Will it ever stop? That's the only other function call we have in there, lazy seek. That's the beauty and the magic of it. It will create a sequence that doesn't get evaluated until you take things from it. Try that in Ruby. So you get back an answer something like this. If you were to take 5 from that lazy seek, you'd get 5 random folks. And yes, I ran this. It's true. I didn't doctor the results. They're random. And turns out quite a few of them are mutants. So again, I'll bet the audience is wondering exactly what we are. How do you find all the mutants? So to find all the mutants, let's take a look at that. We're going to take in some people, and we want to find all the mutants. How many lines of code do you think this is going to be?
I don't know.
10?
No.
15? We should probably get an abstract class with a couple traits mixed in. Yeah, or it's just a one-liner. So the filter function makes use of that predicate that we spent some time making before, and we could use the body of the predicate instead as an anonymous function there, but it kind of fits in nicely, and we just filter it. And we get back, if we took 5 from the other results previously, you get back only mutants. And Magneto's happy. He's found all of them. So let's recap.
Values in the map.
Anonymous functions have their uses. When you get to the infinite lazy sequence, that's where some of the magic of Clojure happens, and you can pour through large amounts of customer data. And we've got a filter function that works on that, and it's really succinct and nice. So, in closing.
So teaching is something you can learn, just like programming. And it takes practice and commitment. And
we are actively working on these problem sets and trying to get them up on Clojure doc. It's a very friendly place. You GitHub pull requests. You can get more content up there. There's already a lot of good content up there, and some of it could use some work as well. But we're trying to find a good place to add these problem sets that give teachers tools to allow them to walk through things with their students and lay it out to do some of the prep work for you. Any questions? Yes?
So how does this training compare to having your student read a book and coming back and asking questions for like traditional kind of?
So the question is, how does this training compare to having your student read a book and coming back and asking questions? And my answer to that is yes. They're both good. They're all good. And this is helpful. Having these types of sessions with your students can help inspire them and get them going.
some of the information that you're picking up in a book, if you're new enough to a language or programming altogether, it can be very abstract, and your vocabulary might not be in a place where it's easy enough to process some of that stuff. So I think it's really, if you're that type of learner, great, or you can couple that with classes or having a mentor or a teacher. Yeah. I think both are great.
Yeah, books are great until you hit something you don't know or don't understand from the book.
Or at times, like for me, I feel like there were moments where I thought I understood something and I didn't. And it took communicating that with someone in order to see that I didn't get it.
Yeah. Question? Say again?
Okay.
And the question is, how do we deal with a variety of backgrounds? We have some Java developers and some people who have some background. How do you mix up the lessons so that everyone gets something out of it?
So the question is, the gentleman mentioned he's working with the Clojure cones, and I'm assuming some devs on your team that you're trying to train up in Clojure. Some have various backgrounds. So some are Java developers, some have some Clojure experience, and just folks are really at mismatched different levels.
I say don't let that stop you, and just marry the two. So if you have someone at a higher level, or he or she can pull in enough information without having to have a lot of questions, then they're going to be able to fly on their own. And you might help more the person that is, coming from a language that's more far-fetched. You're just going to have to marry that, but staying on track with what the katas are. Someone might just go deeper.
have those folks who are ahead of the other folks teach.
Yeah.
Teach the teachers, which is a lot of what we're trying to get across here,
Yeah.
this notion. Let's take it to the next level and start to get the teacher pipeline going. Valuable skill for them, too. Sorry, I'm good. So the question is, have we ever tried the Coding Dojo? I think that's a San Francisco thing or Bay Area thing. There's a Coding Dojo group. Is that what you're referring to?
I've only been in one once, but from what he was talking about, it sounded related because you have a group of people and you're rotating through, one person thinking about the problem, one person on the keyboard, and everybody else helping out. And you rotate.
Okay, so let me say that to the audience. So the person was asking about the coding dojos where you have one person thinking about the problem, one person working on the problem, and then one person helping. More or less, something to that effect. That sounds like a really good idea too. I really like the freedom of our setup by having, we can be anywhere, we can roll out of bed, we could get an idea late at night, hop on Skype and see someone else is on and then start working together, or have multiple, we can have tri-pairs or quad pairs, and if someone has an idea, they roll with it and the others kind of talk and help and refactor. One thing I didn't mention, we didn't mention in the talk, but one thing I found with Clojure that might be really good for the gentleman over there working with Java devs is we have a very different workflow working in Clojure than I have in any other language, where, at least on our team, nothing gets into master without 2+1s on the pull request. So we're constantly refactoring all the time, and we're pairing a lot as well. So your pair's job is oftentimes to really help you refactor all the time. And then when you have more people on, it gets even more fun sometimes. And you end up rewriting the same code 3 and 4 times. But what you end up with at the end is just so much better. And that can be really good for teaching too, that whole refactoring style.
Okay.
This is a comment rather than a question, but I find pairing very helpful if I'm able to do it when I see fit. So if I'm stuck on a problem, I love being able to deal with someone for an hour or two. But I do find the process very tiring, having to explain everything verbally. So one of your slides mentioned that there isn't really a downside to having an apprentice say. But just speaking for myself, I would find it, I would be exhausted at the end of the day after having to spend 8 hours explaining my thoughts and explaining.
So can I answer
let's
this?
repeat it.
Oh, I'm sorry, go ahead.
Yeah, so the comment, yes, and please answer it. So the comment was that we claim that there's no downside to having an extra pair on the team, and it turns out that for some folks when they're pairing, and maybe all folks some of the time when they're pairing, it's kind of tiring and it wears you down to be explaining things a lot. And that does take away from things. So, Denise?
So our Denver team has 4 people, and I usually pair with one of the 3 other people, and we're very verbal about that. If my pair is, if it's wearing and the explanation and they need to just feel like they can get in their groove or whatever, I will switch gears or I'll keep running with code that I can deal with. It's just about communicating. So I think everyone has that, even if your pair is senior to you.
Well, you've also touched on an issue with introverts versus extroverts. And for your typical extrovert, that social interaction is typically energizing. And for your typical introvert, it's taxing. Doesn't mean that all introverts do not like social interaction, but it is good to know more about yourself and know where you're at, and also know the other people on your team and how they like to work.
I mean, ultimately, you're going to grow your depth of knowledge if you're teaching. So if you can get yourself in a position where you're exercising that muscle, you really should. It's a skill. You have to acquire it. And ultimately, if there's not a rhythm between you and your pair, there might be a lack of compatibility. And there's things that you have to do to work with that, like I was saying, like flip it on its head and take another approach, run things differently. So. so that you have a chance to just.
Yeah. Also, one thing that we've been doing lately is we'll have some pair time, and then you've also had little slices of the tickets to work on yourself that are a little easier to wrap your head around than like a full 5 or 8 point ticket or something like that.
And what that's a huge value, and that goes back to that prepare part. So sometimes my pair or someone who's the ticket that I'm working on, they'll take a piece of it and break it down in a gist and say, okay, and then they'll explain that gist to me and say, here you go for it. And I'll keep touching base to say, this is where I'm at, I am completely lost on that, like, can you explain it? And then if I need it, I get the help, and if I don't, I'm plugging away, you know?
And so one thing to think about are using more tools like these problem sets. If you as someone who wants to teach but doesn't want to pair all day and work directly with someone, building up these problem sets and working with these problem sets might be a really good way to interact with someone else. And then when they get up to the next level, maybe it's slices of a ticket like we're saying.
Go ahead.
To help them get through.
Go ahead.
Yes?
So I've done a lot of teaching of functional programming to beginning students, but in a university setting with big classes.
Right.
And the students that we get range from many students who've never written a program before, to others who really have quite a lot of experience, but it's usually in something like C++, and I'm teaching them Haskell. And I found a strange effect there. The ones who've done programming before, of course it helps them. They understand what a syntax error is. They're used to thinking algorithmically. So they make faster progress than the pure beginners, but they often think they're having more trouble because they expect to know what they're doing and they find it's so different to what they're used to. I wonder if you've encountered that, or if you have a way
So let me try and see if I can say that to the audience in the same way. So we have a gentleman in the audience who's a university professor and has taught functional programming to a wide range of students, students with no programming experience to students with programming experience. But those students with programming experience more have things like C++ and more imperative or object-oriented languages under their belt and don't really know how to work in the functional paradigm very well. And so what he's found is those students with programming experience tend to move faster, but have a perception that they're not, and they're not doing as well. Where the newer students don't have this preconceived notion that they're going to hit the ground running, so they don't sweat it. Did I get that right? And the question is, have we hit that or encountered that?
I mean, I personally, I don't have the senior dev experience, but
Not yet.
I feel like I'm moving. Like I don't feel like I'm stalemated by projects, and when I do, I just talk to my peers.
Yeah.
I mean,
So I've been running the Den of Clojure, the Denver Clojure group for
we have
2.5 week time.
almost.
Okay, so we just have a few more minutes, but I'll speak about this. I've been running the Denver Clojure group for a while, and we've kind of run the gamut on everything from advanced macro talks all the way down to install-a-thons just to get pieces installed on people's computers and get them up and running. Windows is so much fun. We've tried beginner workshops, we've tried group problems, we've tried all sorts of things. I don't necessarily know we found all the right formulas for that particular group, but we have encountered a lot of people with various degrees of experience, and we're starting to get a lot more folks in with very little programming experience, which is what got Denise and I thinking about this. How do we start to build up materials and facilities for teaching them? So I have found something slightly similar in that the folks with a lot of imperative or OO experience find Clojure very frustrating at first, but the beginners don't find it as frustrating. It doesn't seem unnatural to them. In fact, a lot of those folks who are just coming into it think it's great because it's simpler. So I understand. I think I understand the phenomena you're talking about. I don't necessarily have good answers for you, except that we should be in our universities teaching functional programming sooner, and that that'll help alleviate some of the problem.
Okay,
time. We're out of time. Thank you very much, folks.